Hey there! Today we're going over part 1 of the 2014-2015 TMSCA General Math Test number 1. Let's do it. Alright, first up, 200.02 minus 98.6 equals what? Alright, so you have to do our simple subtraction here. So 200.02 minus 98.6. Alright, so I like to break up these type of problems to make it easier and quicker to solve. So we can write this as 200.02 minus 98, and then whatever the answer to that is, we minus 0.6 from it, and that's how we get our answer. So 200.02 minus 98 is 102.02, so 102.02. Alright, next, 102.02 minus 0.6. Alright, so that is just 101.42. And that's your answer. Next, 4 and 2/3 plus 19 and 4/5 equals what? Alright, so first let's turn these into improper fractions. So we can do this by saying 4 and 2/3. So we multiply 3 and 4, which is 12. And then we add the numerator, which is 2. So 12 plus 2, that equals 14. And then 14, we just go back to the original denominator. So 14 divided by 3. So that's our new fraction in improper fraction form. Next, 19 and 4/5 is what in improper fraction? So we have 19 and 4/5, so we multiply the denominator and the whole number. So 19 times 5 equals 95. 95 plus 4 is 99. And we add back the original denominator, so it's 99 over 5. Alright, so these are our new improper fractions. Now we need to convert them to the same denominator. So we can multiply both of these by 5 and 3 to make them even denominator. So 14 times 5 is 70. So 70 over 15. 99 times 3 is 297. 297 over 15. Alright, now we just add them. So that is 297 over 15 plus 70 over 15. That is 367 over 15. Alright, now we just have to convert this back into a whole number. So 367 over 15. So automatically we can see that we can do this as a division problem, because any fraction is a division problem. So 15 and 367. Alright, so 15 does not go into 3, so it's a 0. Next number is 36. 15 goes into 36 twice, because 15 times 2 is 30. So we subtract 30, and we're left with 6. We bring down the next number, and that's 7, so 67. 15 goes into 67 4 times. So now we subtract 60, because 15 times 4 is 60, and we're left with 7. Alright, there's no other number now, so we have to bring down another 0. Next, 15. How many times does 15 go into 70? 15 goes into 70 4 times. So we have 4. And now that's just minus 60, because 15 times 4 is 60. So we're left with 10. Next, we bring down another 0. 15 goes into how many times 100? That is 6, because 15 times 6 is 90. And left with 10. So when we get 10 twice, or we get any number twice, it means it's going to keep repeating. So now we have a 6, 6, 6. So that is our answer. But now we need to represent that as a fraction. So 24 and 0.4666. So 0.4666 can be represented as 7 over 15. So our answer is 24 and 7/15. And that's your answer. Next, 4.5 times 9. Alright, so that's pretty simple. Just simple multiplication. So 9 times 4.5. Alright, so 9 times 4 is 36. And 9 times 0.5 is 1/2 of 9, which is 4.5. So 36 plus 4.5 equals 40.5. And that's your answer. Next, 100,428 divided by 4. Alright, so this is actually pretty simple, even though it seems complicated at first. We can break this up. First of all, 100, right? That's pretty simple, because we know 100 divided by 4 is 25. So we all have a 25 already, but this is 100,000. So we have 25,000 as 100,000 divided by 4. Alright, next. So now we have 428 left, and we have to divide that by 4. Alright, so we know that 4 times 100 is 400. So we can break this up, first of all, into 428. So first let's solve for the 400. So 4 times 100 equals 400. So we have 100 here. And 28. So 4 goes into 28 7 times because 4 times 7 is 28. So we have a 7 here. And now we just add all three of these to get 25,107. And that's your answer. Next, the point in -7, 8 was reflected over the x-axis. What are the point's new coordinates? Okay, so here's a rule. If you have a reflection over the x-axis, you're always just making the y value negative. So for example, if you have 1, 1, that becomes 1, -1. But it's the exact opposite for the y-axis. So if you have the y-axis, that makes the x negative. So if you have 1, 1, that becomes -1, 1. Alright, but however, if the coordinate in the x or y's place is negative, and that's the one we have to change, you just make it positive. Alright, so we're looking for reflecting over the x-axis of this problem, and we're given the set of coordinates -7 and 8. Alright, so we just make the y value negative, which is -8, so -7, -8. And that's your answer. Next, find the least common multiple of the numbers 72 and 84. Alright, so the trick for least common multiple, ironically, is actually to solve for the GCF first. So to solve for the GCF, we have to find the difference. So 84 minus 72, that equals 12. Alright, so 12 goes into 72 6 times, and 12 goes into 84 7 times. So 12 is the greatest common factor of 84 and 72. However, let's say 12 wasn't, then what you could do is you could break down 12 into its factors and find the greatest factor that goes into both of these numbers. But that's for GCF. I have more on that in another video of just about GCF and LCM problems. Anyways, continuing on with this problem, LCM. So now that we have the GCF, we can solve for the LCM. So we have 72 and 84 as the two numbers, and our GCF is 12. So we divide one of these numbers. So let's say 72 by the GCF. So 72 divided by 12. That equals 6. And now we multiply the answer by the other number, which is 84. So 6 times 84. That equals 504. And that's your answer. Next, if x equals 5 inches, find the perimeter of the rectangle below. Alright, so to find the perimeter, it's the formula 2w plus 2l Next, if x equals 5 inches, find the perimeter of the rectangle below. Alright, so to solve for perimeter, there's a simple formula, 2w, which is the width, plus 2l, which is the length, equals the perimeter. Alright, so let's say this is our width and this is our length. It really doesn't matter, you can use them interchangeably. So now we just have to multiply each of these side lengths by 2, and then solve for the perimeter. So 4x plus 1 times 2 plus 2 times 2x plus 3. That becomes 8x plus 2 plus 4x plus 6. Alright, so now that we know that, we can solve for the perimeter. So now we also know that x is equal to 5, so we just substitute x for 5 in each of these. So it becomes 8 times 5 plus 2 plus 4 times 5 plus 6 equals the perimeter. Alright, so that's 40 plus 2 plus 20 plus 6 equals the perimeter. So that's 42 plus 26 equals the perimeter. And that is 80. And that is 42 plus 26, which is 80. And that is 42 plus 26, which is 68. And so the perimeter is equal to 68 inches. And that's your answer. Next, which of the following is the correct prime factorization of 200? Alright, so to find the prime factorization, we have to break the number down into the smallest prime number possible. I have more on this on a separate video just about prime factors, But let's continue with this problem. So we have the number 200. So 200 can be divided into 2 and 100. 100 can be divided into 2 and 50. Next, 50 can be divided into 2 and 25. Next, 25 can be divided into 5 and 5. Alright, and we can't break any of these numbers down even more because these are all prime numbers. So quickly, a prime number is just a number that cannot be divided by any number other than 1 in itself. So for example, 31 cannot be divided by any number other than 31 and 1. Alright, now that you know what a prime number is, let's finish this problem. So now we have to find the prime factorization. So the only prime factors we have here are 2 and 5. So 2 times 5. But we need to know the power of each of them, and for that we have to count them. So there's 1, 2, 3, 2. So 2 power 3, and 1, 2, 5. So 5 squared, or 5 power 2. And that's your answer. Next, if two angles sum to 180 degrees, they are blank angles. Alright, so this is a pretty simple problem. It's just a math theory problem. So I actually have a separate video on this just for supplementary and complementary angles. But anyways, let's finish this. So if two angles sum to 180 degrees, so let's say x and y, they add up to 180 degrees, then what are they? So two angles that add up to 180 degrees are supplementary. And if they had asked if two angles add up to 90 degrees, the answer would have been complementary. But in this case, they're just asking for two angles that sum up to 180 degrees. So that's your answer. Next, let m equal the remainder when 621 is divided by 6. What is the value of m plus 18? Alright, so m plus 18. So we know that m is the remainder of 621 divided by 6. So let's solve 621 divided by 6 first. So 6, 2, 1 divided by 6. So that's 6 goes into 6 one time. Subtract 6 and you're left with 0. When you bring down a 2, it goes in there 0 times because 6 cannot go into 2. So you bring down a 1. 6 can go into 21 3 times because 6 times 3 is 18. So we subtract 18 and we're left with 3. Alright, so 3 is the remainder when 621 is divided by 6, which means 3 is equal to m. Alright, now we just have to find m plus 18. So that's just 3 plus 18, which is 21. And that's your answer. Next, 11,111 squared. Alright, so that's actually pretty simple. All we just have to do is know how to square it. So that's just 1, 1, 1, 1, 1 times 1, 1, 1, 1, 1. Alright, so we can now, to solve this, all we have to do is just write this number down 5 times with a 0 at the end each time. So the first time there's no 0, so 1, 1, 1, 1, 1, because that's 11,111. Next time you add a 0 for the 10, so that's 1, 1, 1, 1, 1. So that becomes 111,110. Next you have the 100, so you add 2 zeros, and then 5 ones, so 1, 2, 3, 4, 5. That's 1,111,100. Next, you have 3 zeros for 1,000. That's 11,111,000. Next, you have 4 zeros for the 10,000. So 1, 2, 3, 4. And then 5 ones. 1, 2, 3, 4, 5. That's 111,110,000. Alright, now you just add these up. So 1, 2, 3, comma, 4, 5, and then it starts going down again. So then 4, 3, 2, 1. So we finally get 1, 2, 3, 4, 5, 4, 3, 2, 1. And that's your answer. Next, how many lines of symmetry can be drawn in a regular hexagon? Alright, so to solve these problems, you could either find the formula or draw it out. I prefer to draw it out, so let's draw it out. So we have 1, 2, 3, 4, 5, 6. So that's a hexagon. So how many lines of symmetry can be drawn? Alright, well it's 1 here, 1 here, and 1 here. But then you can also do 1 here, 1 here, 1 here. So that gives us a total of 6 lines of symmetry. But all we really had to do was just count the amount of sides. So hexagon has 6 sides, so the 6 lines of symmetry. And that's your answer. Next, as a decimal, an irrational number is a non-repeating and non-terminating decimal. Which of the following is an example of an irrational number? Alright, so first, let me just say what a non-repeating and non-terminating decimal is. So a repeating decimal is a number that keeps on going. So for example, 4.666, that can be represented with a line over it stating it's a repeating decimal because it keeps going on 6666666. Next, a non-terminating decimal. So a terminating decimal is just a decimal that stops. Alright, so 4.63337. Alright, that stops, so it terminates. So if it doesn't terminate, that means it keeps on going forever. And if it does not repeat, that means it's a random number. So like 4, 7, 9, 1, 3, 2, 4, 5, 6, 3, 9. And it just keeps going on forever. Alright, that is a non-repeating. Alright, now that you've seen what that is, we need to find out which one does not repeat and which one does not terminate. And they have both of those qualities. So first up, 1.7654. Alright, that stops because it doesn't go any further. So that's not it, so it's not A. Next, 23.21 repeating. So that means the number would be like this. 23.21212121 to infinity. Alright, so that's not it because that is a repeating one. Next, 1/2. That's a fraction, so that's automatically not it. Next, the square root of 2. Alright, so in math we have something called perfect squares. So those are your numbers which, if done a square root to, it'll give you a whole number. So if it's not one of those numbers, which in this case 2 is not a perfect square, automatically it's an irrational number, meaning it is non-repeating and non-terminating. So that's your answer. Next, write the number 32 billion in scientific notation. Alright, so I actually have a full video on this just about scientific notation, but let's continue. So, write the number 32 billion. So, 32 billion. So that's 9 zeros in scientific notation. Alright, so to write it in scientific notation, there's a formula where it's A times 10 to the power of B. Alright, so A is just a number that is greater than 1 but less than 10. So that means I have to make a number out of this 32 billion that is greater than 1 but less than 10. So for example, 3.2. If I put a dot right here, it becomes 3.2. And that is greater than 1 but less than 10. So let's write that. 3.2 times 10 to the power of what? So that's what we need to figure out. 3.2 times 10 power what? So to figure that out, we just count the zeros. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So now we have 3.2 and 10 power 9. However, that's not it. We're not done yet. Because this 0.2, or this 2 right here, is also behind this decimal place. Which means we also have to count that as well. So that becomes 10. So we get 3.2 times 10 power 10. And that's your answer. Next, simplify 3 times 5 minus 8 minus 11 minus 2 plus 2 times 4 plus 1 plus 2 plus 3 squared. Alright, so let's solve this. So 3 times 5 minus 8. 5 minus 8 is just negative 3. So we get 3 times negative 3 minus 11 minus 2. 11 minus 2 is just 9. Plus 2 times 4 plus 1 plus 2 plus 3 squared. Alright, so first 4 plus 1 plus 2 plus 3 is just 10. Next you have to do the exponents according to PEMDAS. So 10 squared is 100. Next, 2 times 100 is 200. So we add 200. Alright, so this becomes negative 9. So negative 9 minus 9 plus 200. Alright, so that's just negative 9 minus 9. That's just negative 18 plus 200, which is 200 minus 18. And that equals 182. And that's your answer. Alright, that's it. Thanks for watching. If you found this video helpful, please make sure to show your support. These videos take a lot of effort to make, and I would really appreciate it.